Thermal management is increasingly needed when dealing with electronics to satisfy the objectives of functional integrity and operational integrity. A lower temperature will yield satisfactory function and increase the expected life of the electronics. The application of a heatsink satisfies those two objectives. A heatsink is a heat dissipation device that consists of a base and fins that extend outward. The performance of a heatsink is affected by factors such as air velocity, choice of material, fin design, and surface treatment. When a chip heats up from use, a heatsink removes and disperses the heat to keep the chip at a proper operational temperature. The mechanism of transport is by conduction, convection, and radiation. The heat comes into the fins, and then the flow takes it away by change of enthalpy across the surface. Without the use of a heatsink, the chip could overheat, which could destroy the entire system. To further the heat dissipation ability of a heatsink, the metal can be anodized. Anodizing is an electrochemical process that thickens and toughens the naturally occurring protective oxide layer on the surface of metal. This layer enhances the radiation heat transfer and can also be color dyed to appeal more to the user. The most common material used for a heatsink is aluminum due to its high thermal conductivity and its ability to be machined easily. Copper is sometimes used because of its thermal conductivity, which is nearly double that of aluminum, but it's more expensive and less machinable. There are many types of heatsinks, including extruded, stamped, bonded, folded fin, single fin, swaged, forged, and skived. There are pros and cons to using each type of heatsink, as you'll see in this chart. However, extruded heatsinks tend to be the most commonly used due to their performance and cost. The thermal solution is considered the first step and is closely followed by the preferred attachment method. When it comes to attaching the heatsink to the component, there are several attachment methods that can be used, such as thermal tape, epoxy, wire-form Z-clips, clips, threaded standoffs, and push pins or compression springs. Shock and vibration requirements, in conjunction with demand for high-performance thermal interface material, have led to the increased use of mechanical attachment options. The clip-on method provides the greatest benefit as it makes removal and rework easy. Heatsinks are very common in computers, but are used in a wide variety of industries to cool components. For more information about ATS heatsinks and attachments, liquid cooling solutions, thermal test instruments, manufacturing, or thermal design and consulting services, please visit our website or email us at ats-hq@qats.com.